think we're ready to get started here. Thank you for joining, everybody. Welcome. Welcome. This is the 2022 Best C++ Ecosystems Virtual Roundtable. I am Jim Schultz. I'm the head of community at Incredibuild, and I'm going to be hosting our panel of experts for this discussion. So before we get started, I'd like to do a quick round of intros. So if each of you don't mind, just take yourself off mute and say your name, your company, and your role to our audience. So Anastasia, maybe we can start with you.
Yeah, hello everyone. So my name is Anastasia Kazakova. So I actually spent 8 years in C and C++ development, working mainly in embedded and networking areas. And you probably know me as an advocate for good tooling and product marketing manager in JetBrains for our C++ and also .NET tools. So you might have heard about C-Line, ReSharper for C# and C++, Rider. I also run a C++ user group in St. Petersburg in Russia, where I live, and I joined several conference programs committee just to make sure that C++ events are even better. So that's all about me.
Thank you, Anastasia. And Cameron, how about you next?
Yeah, my name is Cameron DeCamera, and I'm a senior software engineer on the MSVC compiler front end. And my area of expertise and focus is really in C++ modules and tooling around modules and creating the ecosystem that you see in Visual Studio around modules.
Awesome. Thank you, Cameron. Let's fly over to Spain. Hello, Diego.
Hey, hi, I'm Diego Rodriguez Lozada. I'm from Spain. I was a C++ developer for many years in robotics. I was also a professor at university, and the lack of a package manager was driving me crazy, so I quit all of that and I started the journey. I was a co-founder of Conan, and then I joined JFrog 5 years ago. Since then, I'm leading the Conan team at JFrog and leading the Conan project there.
Cool. Thank you, Diego. And Amir, why don't you wrap us up on the intros?
So Amir Kirsch, I'm a dev advocate at Incredibuild and a staff member at the Academic College of Tel Aviv-Yafo. I'm also a co-organizer of the Core CPP conference in Tel Aviv and a member in the Israeli IDEs of C++ national body.
Cool. Thank you, Amir. And so and thank you, everyone. Thanks for giving some quick intros there. That helps a lot. So as part of today's talk, we're going to be discussing the best tools and environments and ecosystems for C++ developers. And we also wanted to talk and list some ideas for some useful things like compilers, build tools and package managers, IDEs or code assistants, static code analysis, profilers, dynamic analyzers, debugging. Did I miss anything, or are there any other items that maybe I left off of that list? I'll throw that to anyone in our panel that wants to jump in.
Probably cloud tooling. That's a pretty big component of our workflow nowadays.
That's a good one.
Yeah, +1 to Cameron for all these tools around the remote work, especially in these days. But I also would like to jump in with testing and like various unit testing frameworks, a very important part of making sure about the code quality of what we do.
That was good. What about like a KMS or knowledge management, documentation, or requirement management?
Yeah, I think those should be in the list of the ecosystem as well, even though I would, in a way, divide the ecosystem into things that are unique to C++ or, tools that are C++ specific, like you need a C++ compiler, probably your profiler is written for C++, knowledge management, version control, architecture modeling, like UML tools, all those are also part of the ecosystem, I would say, but in a more generic way. Probably it's the same tool that you are using, even if you are in Java or other language.
That's a good point. Yeah, a lot of things you need, but maybe a different list for things that are only C++ specific. Okay, cool. So let's jump on to our first topic here. And this kind of leads us into the first topic, right? And I want to start by asking all of you how you select a tool for a certain domain. So a few things you might consider in your response are things like, do you think of open source as an advantage or a disadvantage? Do you think your users are ready to pay for their tools? And also, I'm curious, would you allow two teams in the same group to use different tools for the same need? So for example, two different IDEs in the same group. And And so the way we're going to do this is kind of a round robin. And Anastasia, maybe you can respond to that one first.
Yeah, let me start with that. So to my perspective, the first and maybe the most important is the applicability to the domain and fitting the use case with the tool, because users want their tool to solve their problems, and not to disturb them. So they don't want the tool to bring too much pain. They want the tool to help. So like, for example, people often ask me like, should I use IDEs all the time? And my answer, even though I'm working for, our IDE vendor, is like, no. If you want to make a quick fix for one line of code, and that's very simple quick fix, take any text editor, do the job quickly. Do not, launch a heavy IDE. If you, on the other side, need to refactor the huge code base, that's not for the text editor. Like, use a proper tool, use a full-featured IDE. So that's about, applicability to my domain. And that's not about just like how simple or complicated it is, but about many things. The second probably important part is about the conciseness of the UI and UX, because the developers, they like the compactness, the comprehensibility, the cleanliness of the UX. They want their tool to be, nice, and again, not adding much noise, and this is very important. And then it comes the effect of the team, like if the tool is popular in the team, like if someone is advocating for the product in my team, I will likely give it a try, because my colleague having this tool and he or she kind of appreciate it, why not to try it? So, or if the product has some rules I'm relying on, for example, it has the Clang format config, I will be likely using the Clang format because everyone in the product does that, and that makes no sense to use some other, formatting tool for me. So the same goes for analyzers and all the best practices around that. So I'm following the team rules or the company rules. Then it comes to the, modern C++, if my tool kind of helps me, because the modern C++ is, let's be fair here, it's a complicated language. So if my tool is not helping, then I will probably, put it away and take something which really helps. Talking about the price, which Jim mentioned, I'm from the vendor who is doing the pay tool, and I guess Cameron will agree here with me. So professional tools which bring value, if user appreciates the tool, they will pay the money. And you can see that on the example of the IDEs. In the top 3 or top 5 of C++ IDEs, there are 2 paid tools. There are Visual Studio and C-Line, where both pay. That means that the people see the value to pay for. And that means that probably we're doing our job good enough. So open source tools doesn't always mean they're good enough. So they can be quite trashy, or they can be quite good, like the Clang story, the Albion story is quite nice as well. So it depends. So that's probably the most important aspects from my side.
Great, thank you, Anastasia. Cameron, let's go to you next. What do you have to add to this one?
Yeah, sure. So this is this is kind of a loaded question, and Anastasia hit on a lot of really good points. And I think I'll kind of just go in order here and touch on the open source advantage. For us personally, we've observed a pretty big advantage in open sourcing the STL, where we can have all of these outside contributors start to create features and build up the C++20 standard library without our own devs having to contribute all of that stuff. Now, there's a coordination effort with that. So with open source, it's not totally free. You can't just take every patch every individual submits. There's a lot of moderation, and there's a lot of other types of work that happen with that. But in general, we've observed that it's a pretty big, it's pretty advantageous to have something like that open source. On the other hand, you could open source something like a compiler, which is much narrower than, say, the STL. The STL is a little bit easier to jump into because there's so many things that you could potentially implement in there. Whereas a compiler is very narrow, and it's the domain knowledge necessary for that kind of thing is, it takes a lot of muscle to try and debug through this thing and figure out where the data should be at the end of the day. So I think there's a right way to open source tools. And I think that comes down to what kind of tool it is. And not every tool should probably be open source, in my opinion, simply because you most likely need different kinds of support for it. And this sort of goes into why should you pay for tools? Drawing from what Anastasia said, if the tool is good enough, individuals will pay for it. And the other side of that is you get a certain amount of support, like there's an implied support chain along with paying for a tool. And I think that's something that a lot of individuals really like having associated with their C++ ecosystem. And finally, as far as having different types of tools along the developer pipeline. So say, one person's using an IDE, another person's using like VS Code, another person's using, what have you. I think at that level, it's perfectly fine to let anybody go with whatever tool fits them comfortably. But at some point you need a bottleneck. And usually that bottleneck point is your configuration system or your build system, because everybody has to agree at the end of the day how these components are put together. And so usually that comes down to like a build system or CMake. And you can like say CMake target Ninja or something like that. But at some point, everybody needs to agree like this is how this thing is done. And that's the biggest input I have for that one.
Yeah, I had somebody at another event we did a couple of years ago, and I only remember it because it rhymes, but he said that the rules define the tools, don't let the tools define the rules. So, really understanding what are you trying to accomplish, and then let's go find the appropriate thing, whether it's open source or a paid tool, wherever it is, that's going to help us get there. Diego, how about you?
As much as I agree with the open source advantage, I think the real important bit for me, I'm putting my developer hat here, is having it as an easy and fast onboarding. So in this regard, some things like the community editions, something that you can really get for free, fast, and start using and delivers value from the first day. For me, those are critical. I really need to test things, not for 15 days, not for I don't want the press run. I want to be on my own, to be honest. And I love that, and things like in this case, like Visual Studio Community Editions or Sea Lion or JetBrains programs for developers. I think those are amazing. From that point, I don't really care if they deliver the value. I don't care if they are open source or not. I'm willing to pay, and I'm willing to pay. As they say, if the tool is proving that it is delivering the value, I will pay. I really don't care. But the starting point for me is very important. Not only because of the cost of the initial money, the initial investment, or whatever, but also these kind of tools, in my experience, they have a big enough community. They guarantee a community big enough to find enough resources on the internet, to find enough pressure for the developers to do the right thing when something is failing. The community is big enough to surface the bugs, to improve the tools, to get support, easy support online, and more solutions and more ecosystem around them than the opposite. So I think that's the best combo for me.
Cool, thank you, Diego. And Amir, let's have you wrap up this topic.
I will start with a question regarding open source. I see much value in open source when it integrates with my code. So if I have something that should integrate with my code, I would highly prefer going with something that I control. I can get into the code. And the question is here not whether it is free or not, whether I have the control. When it comes to tools, in most cases, I would not go into the code. I just need the tool. I need to use it. It's not my domain. So for using things in my domain, integrating with my code, I have value. And I prefer open source in a way, or at least something that I can go into the code. When it comes to tools, I agree with the others. Pick what brings you the most value. Regarding picking the right tools or having different tools in the same team or in the same company, I was dealing with that. And I was working in a role where I had to enforce in some cases or let the team speak. And I agree with others, as mentioned before, version control, you have to pick one. in the same company. You don't want some to use one and others to use another one. It's a mess. Using the same database, even across different products. At the end, you want products to be able to integrate one with the other. So you have to, even if it is inside the product itself or things that the product is using, but when it goes to IDEs, profilers, static code analysis, things that helps you create your code. In some cases, I do prefer the teams to bring their own because then I can learn about new things and see if something is better than the other, and then maybe, you know, other teams can take that. So there are things that come from above, top to bottom, like someone has to decide about the version control tool. And there are other things that I prefer to have bottom up. Tim, can you please check if we're using the best profiler? Because I'm not sure that it, you know, catches all the bottlenecks that we have. Let's check others. So this would grow bottom up.
Cool. I like that, Amir. Yeah, and I think most of you kind of touched on this as well. I mean, there's always the value assessment, right? Whether the tool is free or not, there's still a cost associated with using any tool, whether it's open source or a paid tool. And so you've really got to boil it down to that value assessment. What are you trying to accomplish? How much value is this bringing to you? Is it worth it? The cost of using it, whether there's a license or just the maintenance or the effort that I put in to using this, am I getting the value that I need from it? So let's jump on to the next one and talk about some of our favorite tools. And so I'm gonna pose the absolute worst desert island question to all of you. You're on a desert island. You can only bring C++ tools. Which ones are you going to bring? And don't say the ones that'll get me food and water and things. Let's assume all your basic needs are taken care of, and you've got to do some C++ coding on this desert island. Which tools are you going to bring? You know, which ones do you use daily? Are there forgotten yet important domains and tools? You know, what are like your hidden gem type of tools? And Cameron, maybe we can start with you. If you can talk about maybe, you know, a handful, 3, 5, or however many you have on that list.
Yeah, sure. Well, I'd almost certainly say that my deserted island tool is VS Code, and the reason being is because it kind of has everything that I want out of a text editor, IDE. You know, just it's kind of like an all-in-one experience. It's highly scriptable. It's pretty lightweight. It's cross-platform. It kind of just does everything that I want for, you know, C++ development or any other kind of like text editing in general. And really VS Code is my daily driver at work too. So I'm a little bit predisposed to selecting that as my deserted island tool. So, and don't get me wrong, I use Visual Studio as well. And honestly, like when I'm debugging code, I use Visual Studio because for me, the Visual Studio debugging experience definitely trumps the VS Code debugging experience because you get, you know, all the other great things like hardware breakpoints, which we use pretty frequently. That kind of stuff is very useful whenever you're working on the MSVC compiler front end. And yeah, so VS Code is my sort of daily use tool as well. It's my deserted island tool and my daily use tool. And as far as like forgotten yet important domain tools, I'd say there's 2 in this category for me. One is really learning all of the Git commands intimately because I'm generally responsible in our organization to move code from, you know, the product branch from the development branch to the release branch. And so like knowing all of these, all the different Git commands and all of the different merge tactics and all that stuff, extremely useful for anything involving code flow. And the other thing is a good diff tool because diffing is highly useful for that kind of action as well. And diffing is extremely useful for anything involving compiler output or examining like compiler behavior. So in the diff tool I use in particular is Beyond Compare.
All right. How about, thank you, Cameron. How about Diego? What's in your bag of tools?
Okay, so first I develop on Windows. So Cameron, 1 point for me. So yeah, I totally agree with the Visual Studio debugging experience. So if I have to code C++ and debug, Visual Studio is clearly, I love it. For general purpose, I have to say when I need to code in for something for Linux or something, or cross-platform in general, I like CLion. I use CLion. But for Windows, for example, for command line, I love Commander. I don't know if you know the experience of CMD, typically in Windows. I still amazed that so many people I connect with in company, they're still using CMD. And I know the Windows terminal now has improved a lot, but I always recommend Commander. And finally, something that I really use every day for a ton of tons is Python. I really installed Python like the first thing on my Windows machines, basically to automate any other thing. I hate writing scripting in CMake. I hate scripting in any kind of CI system. So everything that I can take out of there and put in Python scripts to automate from a small HTTP server to test my things, or to process some data, or to automate a debugging task, a complex debugging, I will write it in Python. So yeah, for me, Python is very, very important to develop C++.
Well, thank you, Diego. And Amir, what do you bring in?
So I will start with the IDEs. Both Visual Studio and CLion are great IDEs that I'm using and for different purposes. And while teaching, I encourage my students to use both of them, mainly CLion for Linux environments. But I would follow, Jim, your question regarding the deserted island. So I think that, well, let's assume first that it has internet there. So I would like to interact with other programmers and to ask questions in Stack Overflow and learn things from CPP reference and write code on my browser and interact with other programmers, like with tools as Replit or Compiler Explorer or QuickBench or Collirio. So all these I'm using with students when I teach C++, and they are highly interactive, even though I think that both the Microsoft IDEs and JetBrains also go to this direction of being able to give you interaction, being interactive in the cloud. But today for these very simple assignments, I'm using the browser IDEs. And in many cases, what I like about it, that at the end, if I want to play with something or answer a question, I can just share a link to a simple program. So these would be my tools to bring to the deserted island.
Well, thank you, Amir. Anastasia, why don't you wrap this one up here?
Yeah, thanks, James. So first of all, yeah, I would like to say that I'm with everyone here that I would take an IDE to a deserted island. And the main reason for that would be that if you follow our research we do yearly on the ecosystem, which is called the Developer Ecosystem Survey, we are doing that for 5 years in a row already in JetBrains. We are collecting tons of data on like many ecosystems. It's not tied into C++. It's about everything, just because we need to understand our users and what they're kind of using. So and we see from year to year that the people are mostly using the tools which are integrated into their IDE. So if you take a whole bunch of tools in your bag to the desert island, probably you won't be using half of them. But when you have an IDE and everything is nicely integrated, you quite likely will be using that. So the cheapest option is probably to take the IDE which integrates with all the things you need, and then you'll be like happily using these tools. Then I would like to say maybe some nice words about the static analyzers specifically, even though they're quite often, like nowadays, every IDE has a decent static analyzer, and there are lots of tools that are on their own, but they are very important right now. And I see this trend in the C++ right now, how they become more and more important when they help us to modernize the C++ code, which is very important because, again, C++ is not that easy. And when the tool is, pushing you to use something more modern in terms of the language, that's definitely, a winning tool. Then all these stories about the certification, like take the MIST, for example, for now, there are lots of companies doing the automotive, for example, who have to pass the MIST certification, and they're right now trying to come to the tool vendors and ask for the code analyzers, which do provide these mystery checks, so to catch the issues earlier, to make the fix cheaper. And at this point, static analyzer becomes a very, very important tool. Then take the direction the language committee is now moving, like all the proposals by Herb Sarter, like lifetimes, parameter passing, whatever. So they are all about, like, we need to have these things in the compiler, but that will take time for the compiler to implement the things, and then for us, to move to a new version of the compiler, which is regular pain, and some just simply can't move that quickly. But if we may have this in a static analyzer, that's nice, that's perfect. Like, you can have the lifetimes checks, for example, in your IDE or in your static analyzer, that's great. So all these things, or like the concepts or the contracts, so all these things could be checked by the static analyzer. So that's definitely a clear trend in the ecosystem right now to me, that we're trying to request more from the static analyzers to make the code safer and cleaner, and that's actually great. So I would take a static analyzer to the Desert Red Island, definitely. Then it goes to CMake, and that's definitely my choice, and probably the choice of the many people in the ecosystem right now for the project model. Like, we have a zoo of the project models in the ecosystem, and we see again the trend following the dev ecosystem research we do, or following the C++ Foundation Light survey the committee does, so that the CMake is growing, and it's definitely a leader right now. So an absolute leader. So in our research, it grows, like we started the research in 2017, it was something about 34% for CMake, and now it's something about 55%, and it's an absolute leader. In C++ Foundation, it's something about 80% for CMake. That means that if you follow, for example, the Bryce talk at C++ Now, we do have the standard project model. You can, kind of deny it, but we do have it, and it's a CMake, and there are more tools which are tightened to CMake, and that's great. So we probably still will be using others because there are different use cases, and for example, there is the game development where the MSVC is totally a winner, but the CMake is kind of the project model for C++ right now, or at least it's growing to that point very quickly. So yeah, I would definitely take the CMake to manage my projects. And yeah, plus one to Amir about all these learning resources like Compiler Explorer. Like, yeah, it's an essential tool. I don't know how Matt Godbolt feels about it, but that's definitely an essential tool you need to have. And if you don't know, like, the Matt Godbolt is actually an author. So yeah, the Godbolting is not just a verb, that's his surname. So that's a tool essential in the ecosystem right now, which we use to understand the language, to explore the language. Look how many links to Compiler Explorer we have right now in the C++ proposals. So that's just what we do. So we're writing the proposal, we're just putting the link to the Compiler Explorer to explain what we mean. And then some resources like the wiki we have, the CPP reference. That's just a small wiki, but it's great because if I don't know something, I won't be digging into the documentation or into the standard. I will simply go to the CPP reference and I will search there for what I need, and I will look when the feature was added, like what the standard it requests, so what's the header file or what's the library, all the details, and I will find some nice example and I will try to adopt it to my code. So these tools for me are essential, and yeah, I would take them to any island.
Awesome. So it sounds like a really fun island with all these people coding with C++ and all these tools. So let's move on to the next topic here, and I want to talk about changes to the ecosystem. So aside from everyone working remotely now and all of the Zoom meetings and everything that we're doing, I want to talk about what's changed in the last few years. What improvements have you seen in the C++ ecosystem? And has a standard C++ developer's work process really changed that much? And if so, how? And Diego, let's go to Spain and start with you on this one.
So I think in the last years, what has happened in the C++ ecosystem is a change of mentality. So developers, they were C++ developers. Now they are turning into real software engineer. Because in the past, I recall not so many years ago, people were proud in C++ we were not doing unit tests at all. So you could find really many projects without unit tests at all. And they were proud of that. I think that has completely changed. And now we have great tools We have, of course, catch2, but also other things more advanced like fuzzy testing or behavior testing, like the approval test from Karl. Those libraries, they didn't exist 4 years ago, or they were not, but today they are being used by people more and more every day. So I think this change, this shift left to developers. Now they are also concerned about all those things that Anastasia was also commenting, sanitizers and CPP check, CPP depend, clang tidy. Now developers are aware of these things. They are integrating them into their tooling. They are making their code explicitly, doing efforts to improve the code over time, which is the definition of software engineer. And we can also see these IDEs also doing the efforts to integrate those tools at once. So everything comes together to finally deliver better code over time, which is the final goal. And also other tools for building. It's not only the developer is not concerned anymore with their own small part of the code. They are also concerned about the CI, about the speed of the CI, and they want fast builds. And they want fast builds in their machines. They want fast builds in their CI. So they start to use SCAS, Incredibuild, CCAS, and also doing proper software engineer to their code, to decouple dependencies, to split things into smaller modules, to investigate the modules, of course. Goal to improve all of this is also very important. And in this trend, we also see another trend is the tool of package managers as an enabler of this. The moment you add another layer of automation that can manage your binaries, for example, migrating from one compiler version to the next one is easier. And then getting advance of all the new tooling that comes with the new compiler versions that we need C++ standard becomes possible. It's not a real pain to migrate your project from one version to the other, because you now have more tools that help you with that. And that is also better software engineer at a scale to help with your. I think this is the big shift in the last, not so much, like 5 years or something. This has completely changed, and this is continuing in this direction.
Well, thank you, Diego. Amir, let's go to you next. I know you've seen some big changes in the last few years here. What do you have to share with everybody?
I think that in a way, C++ becomes younger. I think a few years ago, you could have found projects that, stayed with C++ 98 saying, well, I don't know what is the horizon, what is going to be the next version of this product. And we see today more and more new projects being written in C++, projects that were C are moving to C++. Projects are refactored to the new versions of the language. So companies understand, companies that are using C++ or are going to use C++ understand that this is a live language, and as Diego just raised, and it should be used as we use other languages. Like, we need the proper tools, we need testing, we need package management, we need fast builds. So it's not this old language that has its own rules. It's, part of the development ecosystem, and everything that we see works well for another environment, we want it as well in C++. And this goes also with static code analysis tools, etc. So the language in a way evolves, and the ecosystem evolves. The language and the ecosystem sees other languages, other environments. It is being affected by other trends. Like, for example, I think that Rust affects C++ in a way that we see more things being checked in static code analysis, more things into the language. So we would have the safety in the language. And this is, I think, being affected by seeing other things. And we say, yeah, we can have that also in C++. Other things that I see is that compilers, and this is, I would say, in the previous few years, are giving much clearer compilation errors. You can even understand what the compiler says to you, and this is very important for juniors and students. And the compiler says you have most vexing parse. You need to remove the parentheses. And before that, it didn't. And again, the reason is competition between tools. You have a new compiler which has better compilation errors than the other one says, okay, I also need to improve that. And then the first one also improves what needs to be improved. And this is a good trend for the ecosystem and for the language. And I see it being used by actual users. So it's not only, just a theory. It's going to the production floor.
Well, thank you, Amir. And Anastasia, let's hear from you. What's changed in the last few years here?
Yeah, I first would like to make a small comment to what Dayaga and Amir was saying. So actually, while I do agree that the value of, the unit testing and the modern standards is kind of growing, but still what we do see for the last 5 years in the ecosystem is that the share of those who are using the, C++ 9803 is still pretty much stable. So probably these legacy code bases are not going anywhere. They're not planning to migrate, so we still have to deal with them. And also there is quite a big share of C++ developers who are saying that they're not using unit tests at all. And I was, doing my best for the recent 3 years trying to adjust the question to make sure that I'm really understand them right, and they're really not doing any unit tests at all. And that's something about the 30% of the C++ developers feel in the survey. And I still is very much surprised with the result. I'm still trying to, to ask more in this question to understand why they're doing this way. Maybe they're using another way of testing the code or something different, which may be the case for embedded developers where they have, their own tools for that area. But still, it's a very surprising result to me. And talking about the actual trends, the improvements in the ecosystem in the past 5 years. So like I mentioned already, the project model, the CMake, which actually is there, and it really it was growing through all the recent 5 years to this first place in the ecosystem. I also mentioned before the value of the static code analysis, which grows significantly, and I think that partially this success is because of the Clang. How it's widely used, how the Clang tidy is customizable, and how developers are learning how to customize the Clang tidy for their own needs. So that's not just about the Clang tidy checks which are public, like the Google who is contributing to the Clang tidy, or there are many other checks, but that's how the companies are tuning the Clang tidy for their own needs, and that's the part of the success probably. Then the general trend which I see now in the ecosystem and among those who are in the language committee is that we now all understand the value of the toolability aspect of the C++ features. Because 5 years ago, I was making, I was kind of making the talks at the conferences, trying to explain from the vendor perspective which issues we have with the language features when we're trying to implement an IDE, a tool, like why we do care about the result when we're trying to highlight the code, because it's C++ and you kind of need to resolve the code, not just, parse it to highlight the code, which is a very basic operation. And this is what you don't need for Java, for example, but you need it for C++. And 5 years ago, that was something very new to the people and to the language committee. And now, we have this tooling working group in the committee. They do care about the toolability aspect. They understand that that's important. And if the C++ feature is not toolable enough, the adoption won't grow. So the people won't be using the feature if the tools, if they can't support it. So I think that's a very important trend, and that's a very good trend for for vendors, but we also, we understand the responsibility. We need to create tools for the new features of the language and to support it quickly, take the modular story, no one will be using it without, proper tools which really supports that. So, and the last thing I would like to mention here is take our current reality. So we are having this online webinar. So we're mostly online right now. We are doing online conferences. We are working online from home, and we have cases when the code base is disallowed on my local machine. It's only allowed in the office, and so you're staying with this laptop, and you need to work with the code base in the office, which is maybe closed, or your home laptop is not powerful enough, but you still need to do the job, or you want to collaborate with your colleague, and you're kind of tired of sharing the screen in Google Meet or Zoom or whatever you use, and you just want your tool, like your IDE, for example, to do that. And all these aspects of distributed environments and remote, they really grow. That's our new reality. I call it remote reality. So like in JetBrains, we realized that a few years ago that we're going into this direction, and it was pushed hardly by all this pandemic situation. And like we just released yesterday a whole bunch of tools for remote, a whole new IDE built on the distributed, architecture. And that's all because we understand that for example, the IDE of the future will be the distributed environment. It's not something working locally. It's something that could work with, whole bunch of distributed environments with unstable connection, which I would like to warm up maybe on the server to connect, to do some job quickly, then connect to another one. So all these things are essential, and they're coming to our reality as the essential tools. And that's the trend, which is mostly not the recent 5 years, but the recent 2 years probably of the pandemic is pushing hard.
Very cool. And I think I have some links that we can share in that regard, Anastasia, in the chat too. So everyone who's here, check the chat. We'll share some more details around this. Thanks for sharing all that. So Cameron, Seattle, you seeing the same changes as the rest of the world?
Yeah, I think Anastasia, Amir, and Diego all pointed out excellent points as far as trends go in C++ in the last 5 years. And I think like playing off of Diego's point where, upgrading to a newer compiler version is getting a little bit easier nowadays. And the thing that we've noticed is that projects which are still being actively maintained, or even new projects, are very willing to take compiler upgrades and fix their source issues and things like this, just to take advantage of newer compiler features or newer optimizations that a newer compiler can offer. So that's a pretty big trend that we've been seeing that hasn't been a thing in 5 years prior, for example. I noticed that a lot of companies, before that period would just kind of lock on one version of Visual Studio or MSVC and just say, we're just gonna build this thing this way forever, and then we'll kind of like maybe maintain it every now and then. But now it's more of, hey, let's reinvigorate this code base and sort of bring it up to modern C++ and see what we can take advantage of. So that's one thing that we've been really seeing as a positive trend. The other thing is that, and Anastasia kind of alluded to this, which is just leveraging more cloud resources in general. So I can't imagine a time, working on the compiler where we didn't have cloud resources. Like the thought of that is just so painful to me, because, for example, on every single commit, we run about 1 million tests on the compiler, and I can't even fathom how we would do that without a cloud environment. Same thing for building all the compiler. Like we build 10 flavors of the compiler. So doing that, on a single machine would just be, it would be a complete waste of time and developer resources. So taking advantage of cloud resources in modern C++, in the C++ ecosystem has been hugely advantageous to productivity and really optimizing developer time in general. So that's the main thing that I've been noticing.
Isn't that funny how quickly that changes? It wasn't that long ago that you didn't have cloud resources available. Now you can't live without it.
Yeah.
It's like walking into a restaurant. It's like forgetting your phone at home, I never had a phone when I was a kid, and now I can't go anywhere without it.
Yeah.
Cool. I actually, I have a question for the group too before we go on to our final topic here. Is I'm just curious about the talent pool and the expertise around C++. Has that been harder or easier to find in the last 5 years than, say, the previous 5 years?
It was hard, and it is still hard. So I wouldn't say it became easier or harder. There is a very old post by Joel Spolsky on academic institutions going away from C++ to Java or Python. He called it the perils of Java schools. So we have today less academic institutions who teach C++ as the major language. This is a problem. It's not so hard because eventually those who want to learn C++, because I would say the problems that we code with C++ are more challenging, are more interesting. So it can grab those who seek for the more challenging and more interesting stuff, and those come. And we see new domains like automotive, like finance, Many new domains that are now attracting C++ developers are being written in C++. So eventually we do have the talents, but I don't think it became easier. One thing is important. I think that youngsters today understand that C++ is a live language. So picking C++ is not something that, well, it's interesting, but I don't know if it's a niche or if it would survive the next 5 years. Everybody knows today that, yeah, it will be there when maybe other very popular languages would disappear. I don't know, Ruby. Ruby was very popular. I don't know many new projects being written in Ruby or PHP. C++ would be there. So,
Yeah.
so this brings people who understand that, yeah, when a new graduate who seeks what would be his next role, his first role, would consider C++ as a very good opportunity to deal with sophisticated, complicated challenges.
Right. That's it. Yeah. Thank you for all that feedback, Amir. It's interesting because you look at things like the CPP cons, right? Those keep growing in numbers. So the more people are hearing about it, or it's actually becoming more popular with more vertical markets and other projects. But that kind of brings us to our last topic here too, where I want to talk a little bit about the future. I think we have the right audience here. I think everyone's going to agree that C++ is definitely the future, right? It's the language of the future. That's the thing that everyone's going to be using in the future. So I want to talk about where do C++ ecosystems go in the next, say, 10 years? Are we looking at a tendency of cohesiveness between different languages? And what about language agnostic ecosystems? And for this one, Amir, I think it's your turn to start first on this one.
So I would shortly shed some light here on AI. And there are today already tools like GitHub Copilot and Tab9 and others, and you see that in the IDE itself, that assist you in writing code. So I would say that we would see more of a trend into, okay, I see what you are going to write, okay, and you can just, get the proper, in some cases, it would just take off all the code that you wrote and replace that with a call to a std algorithm or some library.
Thank you, Amir. And how about you, Anastasia? Where is C++, the language of the future, going in the next 10 years?
Yeah, I'm kind of still thinking about this nice and shiny world Amir described. Would like to try it out. So so to me, like, even though the modern development is a lot about the multi-language development and cross-language development, I still, kind of don't believe in a general purpose programming language. I still think that each language has its own area, and there is a language for the particular tasks. And C++ is a key for areas with low latency, with real time, with low reply times. So like embedded or trading or banking or other financial systems or game development, or the IE or self-driving. So everything is in C++, and it's an essential language for these areas. And I don't think anything will be changing in this way. I think they will still be in C++, and these are the critical areas. These are the essential parts which you have to write in C++ because of the C++ goodies. So, but I think that what we might get in the next 10 years is maybe form somehow a standard ecosystem, maybe with some options, but still, like, we'll have this CMake, we'll have something like Clang Tidy or some other Clang based tools or Clang format, then, maybe a set of package managers, maybe like, as Bryce put it in his talk again at C++ Now, so maybe we won't have like, a clear winner between a Econ and a DC package. They can both exist because they serve different goals, different tasks. But for example, we might standardize the package description to make it easier, to maintain the packages. So I would really hope for having a more standard ecosystem in the next 10 years, because right now we realize how important it could be, how valuable it could be. So maybe we can come to that. And we still will be borrowing best practices from Rust and other languages, and that's totally fine. Others do as well, like they borrow from C++. So we all do that, and that's absolutely fine, because like the languages, they evolve, and that's great. So I do hope that, yeah, we can evolve as well in the way we do right now, and maybe, yeah, form something like a standard ecosystem and make more tools which are helping with the language and not just, somewhere aside. So that's what I do hope for the next 10 years.
Well, thank you, Anastasia. Cameron, how about you?
Yeah, I think Anastasia touched on a really good point, which is, the agreement on what package management should look like in C++. And historically, C++ has never had really an agreement on what it should look like or what it should do. And I think there's a lot of really good approaches right now. Maybe not necessarily one that we could standardize soon, but there's a lot of really good ideas in thinking about how package management works, especially with, the C++ 20 feature modules and like how that might look in package management in the future. So I think there's still some open questions on package management and how we could potentially standardize it, but there's a really good upward trend on how that problem is being solved today. And I think VC package is a really good example of how, package management could be done. And even VC package has even gone out and modernized some of the older libraries to have to put in like CMake into their build systems. And so it makes it really easy to integrate. So essentially anything you would find in the VC package library will have a CMake hook. So that I could just go off and build whatever it needs to do, despite whatever the project may have started with originally. And I think that's a pretty good thing for modernizing C++ going forward, just moving them into a modern package manager and thinking about how it looks when it's integrated into newer projects. The other thing is, I think there's a really unique opportunity moving forward with C++, in particular with the advent of modules. And I think that the use of modules goes well beyond just compiling code. And I've mentioned this many times, and Gabby has mentioned this many times, but really the semantics information that's put into a module that's persisted is something that you could process and you can write tooling around in order to do things like automatic language bindings. And we've done proofs of concept using that in the past, or even just analyzing all of your translation units in a way that you couldn't do before. So usually static analyzers will generally analyze a single translation unit, which is good, but it's a pretty narrow point of view of the entire program. And with modules, you can kind of get like this cross translation unit static analysis thing. So, and I think that's something that we really need to think about in terms of tooling and what the ecosystem could do moving forward.
Thank you, Cameron. And Diego, why don't you wrap up this final topic here?
Yeah, I think I agree with what has been said. I think in the next year there will be some stabilization, some standardization over the C++ building experience, and I agree that the way to go is to have a common package specification that will allow many players to be there. So I think the ecosystem will mature in that direction, and it will be good for everyone. Actually, it will not only be good; it's necessary. Otherwise, we will not survive. As cool as C++ and Power, if this doesn't happen, C++ is going to be out of the game. So I think this will happen because it needs to happen. Regarding also the point before, if the companies, they are not doing this, they are not using the latest tools and the coolest tools and the latest compilers and everything, they will not get the developers. The fight for the talent pool is there. It's not only in the project, it's also in the tooling that is being used. And finally, regarding the artificial intelligence thing, I'm a bit skeptical that the code generation will actually be a big breakthrough in the next years. But I think something will happen, not specifically in code generation, but probably, I don't know, in testing. Maybe in testing, there is a big breakthrough that might be cross-language too, that helps to develop and run tests at another scales, or might be other thing. It's very difficult to know. Come on, 1 decade is C++ 11. So the language can be completely different. So in this regard, for example, there is a project that is called TP-Build. It's the second attempt to actually generate build scripts on the fly. It generates CMake scripts on the fly based on the analysis of the source code. I think these things, if the artificial intelligence gets there, it can be a game changer. Not necessarily in code generation, but in tooling, some small thing that will empower. It will not replace developers, of course, that will not happen. But it will really empower C++ developers in the next decade.
Thank you, Diego. Yeah, good, very interesting insights from everybody. I think we should all agree to do this again in 10 years and see how right all of you were. Before we wrap up here, there are a couple of questions in the chat and in the Q&A. If you guys have a few more minutes to stay on, I can just rapid fire these to you. Let me go back up to the first one. Oh, so anybody can answer this. What is your favorite C++ static code analysis tool?
ClankTidy.
Amir, you have one?
I was using CPP check, which is not as strong as ClankTidy today, and ClankTidy is being stronger. So this would be also my choice, but there are other very good commercial tools. So I would not go by listing them, but there are others to check.
Well, it looks like Cameron, you might have had a response.
Yeah, generally just the static analysis tools that are available immediately in Visual Studio are pretty good. And if we're talking like outside of static analysis, things like ASAN are really useful for finding really weird latent bugs in your program. So I would definitely want to plug that for sure.
All right, cool.
Yeah, I would +1 the ClankTidy, but not the general one, but the one we do maintain with C-Line team, because I'm really impressed how the team kind of enhance it with more checks and what we can do with that. So that's the best example to me how we can, make the good tool even better. So yeah, that's for me.
Cool. Let's. The next one is. Any alternatives for CMake? Maybe let's just go in the same order. Diego, do you have any alternatives for CMake?
Yeah, it's a hope. It's a wish. I would hope that Meson would have been the winner, or specifically anything. But I like the initial idea of SCons. It didn't get traction enough. So I think the next competitor us today would be Meson. I think Meson is a good build system with good defaults, good ideas. It's challenging, but I like it. I think it's worth giving a try.
How about you, Amir?
So there are others out there, but I think the numbers are what is important, because eventually you do not want to stick with something that would not catch the market. So this is a question of what is the standard. And today, as Anastasia raised, CMake is de facto standard. So this again would be the obvious choice. There is Ninja, again, and other options, but and some of them generate CMake, some of them integrate with CMake, but again, CMake is still the king in a way.
Yep. Yeah, Cameron, anything to add to that?
I mean, I couldn't agree more with, the comments that were made before. It's really hard to beat CMake and its cross-platform support. In terms of other build systems that were on my radar that are kind of interesting, Boris Kapitchkov, the build system build 2 is really interesting because of the way that it ties modules together, C++ modules together. I think that one's worth at least looking at to see, how does a build system take package management and C++ and tie them together in one unified package?
Anastasia, anything else to add? Any
Yeah,
CMake alternatives?
I would kind of like ask in return, like if you're looking for alternative for CMake, what's the problem with this CMake? Like I totally agree that CMake has some, not very good syntax, and it has lots of issues with the language itself, but it's kind of great in terms of the cross-platform project model, Bell system, and it's very, very popular. But if you're looking for the alternative, you probably have a strong reason for that. So you probably have the use case where the CMake doesn't fit. Like if you are, for example, in the embedded is very slowly moving to CMake. It's mostly about the make file. So probably you're with make files because everyone is doing that. That's fine. For some tasks, like compilation database could be good enough. I mean, like, why not? It's simple enough. You can tune it easily, and lots of editors can, cope with it. So that depends on the goal. So if you're looking for the alternative for that standard tool like CMake, probably you have a case, and then you need to find a proper tool for your case. That's it. So for me, I was mostly before JetBrains, I was using CMake, and I was actually participating in the porting the project from Makefile to CMake. That was a nightmare for a couple of months, but after we did it, everything was great. So for me, CMake is good enough, but that's only saying about that I have a proper case for it.
I want to add that there is a question of combining, in a way, the build system and the package management system, and if there are good answers in this domain, then might be that we would see either new approaches or new tools. But again, today we have CMake as the winner in the way that it is mostly being used. And for package management, we have additional tools to work with. It might be that at a certain point, we would see integration of inside a single tool, or things that are integrated as being a single tool.
Well, thank you, Amir. Thank you all very much from around the world for joining us here. This was a really, really great topic and great discussion. And I'd also like to extend a huge thanks to all of our viewers today as well. Thank you for joining us, and we look forward to seeing all of you on the next one. Thank you, everybody.
Thank you.
Thank you.
Thank you. Bye.